Okay, here's the first one. We're asked to, and I can see why these are kind of tough. There's some math to do with these. Okay, everybody with it? All right. So we're given, this is like an example that we went through a couple days ago, where we're given, in this case, a volume, and we got to find the missing dimension. So now what do we do with this? How do we always approach these problems? How do we always do these kind where we're given a quantity and asked to find a missing dimension? Where do we start? Write the formula. Absolutely. Okay, so we're going to write the volume formula for a pyramid. What is the volume of a pyramid equal to?
1/3 times base times height.
1/3 times base times height. Very good. Okay, and we're looking for the height this time, aren't we? Trying to solve for y. Okay, good. So all we got to do on these is we've just got to figure out what b is, and the volume is given to us, and then I can plug that stuff in and solve for h, isolate h. So what's the shape of the base on this one?
Square.
Tyler, why don't you grab yourself, come on up here, please.
15 squared.
15 squared, very good. So easy, it's 15 by 15. So we can solve for b. 15 times 15, which is 225. Okay, so we got b, we've got v, that's given to us. So I can plug all that stuff in, and I get 2706 equals 1/3 times 225 times h. Now, what are the steps I go through to solve for h? Okay, I can divide by... Okay, yeah, I could divide by 1/3 times 225. That's fine. I could do that. I could divide by that whole quantity, and that'd be fine. Or if I do them one at a time, what could I do? Okay, could multiply by 3 to get rid of the 1/3, right? Let's try that. So what if I multiply by 3 over 1? And I've got a calculator here ready to go. So if we do that, we get we get 8118 equals 225h, and then so the last step,
Divide.
divide by 225. And then the 225's cancel, and I got my h, and so I could, if I just hit divide, it'll take my last answer. Divided by 225, there it is, 36.08. They want to round it to 2 decimal places. There it is. Okay, questions? No big deal? Okay, good. Good, good.
We're here all day.
Today we're here, yeah, but I'll give you the next two in the lab. All right, find the surface area of the regular pyramid or cone. So this is a matter of just plugging in to the formula. Now on these, it's harder maybe to see what's going on with these than it is with a cone, but they're not that different. They're really not that different. So if we're trying to find surface area here, what is the surface area of a pyramid? Okay, we got our base plus 1/2 base perimeter times the slant height. Okay, so a lot of this stuff is given to us here. What is the slant height? Y, yeah, and that's 30. They give that to us, right? How do I find, now what's the shape of the base? This one in particular, people have equilateral triangle. People have a hard time seeing that. But here's the base. If we do the base in red, this is what's sitting on the table, right? Now that one's dashed because it's behind the shape, so we're looking through the shape at it. But that's the base. Everybody see that? How do we know it's equilateral?
The x's.
Because we've got these x's are the side lengths for all three sides. It doesn't necessarily look equilateral, but we know it's equilateral because all the side lengths are x. They're all the same.
So pretty much to find out the base, we would have x.
Okay, to find the base. Now, how do we do that? You got to be a little bit careful because we can't just do base times height here. If it's an equilateral triangle, we don't know what the height is, right? It's not obvious to us. But we have a formula for an equilateral triangle. Does anybody remember what that is?
3 times 3.
Aha, good. The area of an equilateral triangle is the square root of 3 over 4 times x squared, or s squared, whatever you want to call it, the side length squared, right? Side length is 12. So then in this case, we get b equals square root of 3 over 4 times 12 squared. That's just a number I can get on my calculator. Now, what's the perimeter of the base going to be? That's always really easy. Perimeter is piece of cake.
12 times 3.
Yeah, it's just going to be, I've got 3 sides and they're all x, right? So it's just going to be 3 times x, which is 3 times 12. So 36, right? Okay, so now we can just plug this stuff into our calculator and we're done.
No, you don't have L.
We actually do. They gave it to us. L was y. See, remember, the slant height is the distance up the middle, right, of the face. Okay, good. Yeah, now if we were looking for volume, we'd have to calculate height. But we're looking for surface area. So B is, we said, the square root of 3, get out of the radical, divide by 4, times 12 squared. Okay, so there's the number that goes with B. The perimeter we said was 36, so we can go ahead and add this thing up now. We've got this number plus 1/2 times P, so 0.5 times 36 is our perimeter, times the slant height, which is 30. And just like that, we got it. 602.35. Done. Okay.
And that's for a...
That's for surface area. That's for the whole surface area right there. For triangular, an equilateral triangular pyramid. Exactly. Okay, now I want to just show you that there's another one that came up on here. And if you get this one, I guess you kind of luck out a little bit. Because this one, why is this one easier? What kind of shape is that? How would you describe that? Okay, that also is a equilateral triangular pyramid. But this time, notice that all of the faces, all we have are x's there. Every side, or every edge length is x. So how many faces are there on that thing? 4. And they're all equilateral triangles, right? Mm-hmm. So it would be the easiest way to calculate the surface area of this thing. You could kind of cheat on this one. Yeah, 4 times the area of an equilateral triangle. So I could just do my formula, square root of 3 over 4 times x squared times 4. And really the 4's would just cancel it. Okay, but I could just calculate that and multiply it by 4. Okay? All right, what about this? Find the unknown dimension A if x represents the surface area of the solid below. Okay, so, and they're giving us surface area is 973. Now, what's the surface area of a prism? Okay, good, I'm hearing it. Good, 2 bases plus the perimeter of the base times the height. Good. And what we're looking for now, we want to set this up. Remember, we would like to have the bases, if possible, be the faces that don't include the missing dimension. We'd like the bases, we'd like to be able to calculate the base, a number for the base, right? So what should my bases be then? Okay, good. They should be the faces that are y wide by w high, right? The front and the back. Right, so if we wanted to set it on the base, we would grab this thing and do that to it, right? Tip it forward, maybe. So it's the front and the back or the bases. So let's calculate those. So then, this is now, when you're dealing with rectangular prisms, the areas are super easy to calculate. It's just, how do you calculate the area of a rectangle? Length times width, yeah. So base would just be y, which is 5, times w, which is 16. So 80. That's the base area. Okay. And then the perimeter, how do we do the perimeter of the base? It's going to be, well, not A, right? It's going to be y plus w plus y plus w. So 2 y's and 2 w's, the distance around the base, right? You'd have two heights and 2 widths. So 2 times 5 plus 2 times 16, so that's 10 plus 32. 42 is the perimeter. Okay, so we got everything we need. We know the surface area, we know the perimeter, we know the base, and we're trying to find h, right? So we can set this thing up as an equation now. 973 equals 2 times 80 plus 42h, right? So what are the steps I go through then? And we can just solve this right into our calculator. Okay, good. We got 973 already over here. If I want to get the h by itself, I'm just keeping track of all the stuff we accumulate on the other side, right? So 973. First step is to, say it again? Okay, subtract 2 times 180 because that's being added, right? So first I got to subtract that stuff away. Remember, we're reversing order of operations. Okay, so minus 2 times 80, which is just 160, right? Okay, gives us that. Okay, good. So let's keep track of what we've gotten rid of here then. So this stuff is gone. Now what? Divide by 42 and we're done, right? So we'll just divide this last stuff by 42 and now we got the h by itself and it's 19.36. Okay? Make sense? Okay? All right, what about this? Now this one, a lot of people miss this one, and the reason they missed it is because they're leaving off one of the parts of the surface area. Now let's read this carefully. The center of the sphere is at C, and its circumference is 5 pi. Okay, if the sphere is cut in half as shown, and the two hemispheres are separated, what is the surface area of one of the hemispheres? So I've got 2 parts to it, right? I've got the dome part. And how do I find that? How do I find the surface area of the top dome? Because when I cut them in half, they're like those little snow globe things, right? Those little Christmas ones that shake up and stay. What do you think, Gene? Okay.
4 pi r squared.
Okay, good. Half the surface area. So first we got to find the radius, good, and then we'll plug it in. We'll take the area of a sphere, calculate it, and cut it in half. But then what's the other part we have to include in the surface?
Circumference.
Not circumference.
Area.
Okay, yeah, the flat area of the base that we've created when we cut this thing in half, right? So we got to add the area of a circle to our surface area, which is what? Pi r squared. Okay, so let's find r. So we know the circumference, 2 pi r equals 5 pi. I've got to solve for r. What do I do to solve for r there? Okay, divide both sides by 2 pi. So the 2 cancels and the pi cancels, that's good, and I get r equals, pi's cancel, right? What's 5 divided by 2? 2.5. So that's my radius, right? So then if I want to calculate the total surface area, I've got to calculate, I'm going to do 1/2, so 0.5 times 4 pi r squared, right? There's the surface area of a sphere, times 1/2, plus pi r squared. Because this is the circle, the base, right? And this part right here is just half of the surface of the sphere, hemisphere, right? Okay, so we can throw all that stuff in our calculator and make short work of it, no big deal. So 0.5 times 4 times pi times r squared. 2.5 is r, so 2.5 squared plus pi r squared. Pi times 2.5 squared. Yeah. And we got it, 58.90. Okay? No big deal. All right. Okay, this to me is one of the harder ones. Find the surface area of the figure below. Okay, so we got it's a pyramid, right? So we're going to fill in all the parts of our formula. Surface area of the pyramid, you already told me, was the one base plus 1/2 p L. Base is pretty easy. We got a formula for that. What's the shape of the base? Good, regular hexagon. Perimeter of the base is very easy. How do I calculate the perimeter of the regular hexagon?
6.
Yeah, 6 times x, because x is a side length of the base. The part that's a little tricky on this is slant height, L. Okay, now they're giving us the edge length, aren't they? Right? And so we want to find this distance up the middle. We're looking for that, right? And so what they're actually giving us is this. Okay? But we can use Pythagorean theorem. So if y is 11, we know the red length is 11. What is that distance going to be in that right triangle? 2. Okay, good. It's half of x, isn't it? So that's 2. And then that distance is L, right? So if we pull, let's pull that off the face, that right triangle we've created by cutting the face in half. And it should just look like this. There's L. There's y, so that's 11, and there's 2. Okay, so what does the Pythagorean theorem tell us about those 3 sides of that right triangle? Okay, and a and b would be L and 2, right? And hypotenuse in this case is 11. So I get L squared plus 2 squared equals 11 squared. So L squared equals 11 squared minus 2 squared, right? And L, then, is equal to the square root of L squared, of 11 squared minus 2 squared, right? Okay, so I got L. I can put all the stuff in my formula then. Oh, and by the way, the base, our formula, does anybody remember what the formula is for the area of a regular hexagon?
3 squared.
3 times the square root of 3 divided by 4 times the...
Divided by 2, actually.
Divided
Divided by 2.
Times the side length squared.
Good. That's it. Okay. And you can also, if you want to, just take 6 times the area of an equilateral triangle. Same thing. Okay. But we can make this calculation pretty easily then. All right. So if we plug all this stuff into our calculator, then let's calculate the base first. Let's get a number for that. So 3 times the square root of 3, get out of the radical, divided by 2, times, what was the side length? I forgot. 11, no, 4. Okay, times 4 squared. So there's our base area, right? The base perimeter would just be 6 times 4, so 24, right? So we can just plug into our formula. Surface area is B plus 1/2 PL. Let's calculate L while we're at it. Square root of 11 squared minus 2 squared is that. So there's L. Okay? So then our total answer just looks like the base, right there we calculated, plus 0.5 times the perimeter, which we said was 6 times 4, so 24, times the slant height, which I'll grab right there. And that's our answer, 171.37. Okay, that's probably the hardest one on there. All right, this one a lot of people had trouble with, but the reason they had trouble wasn't because they couldn't do the math, it was because they didn't know how to interpret the last part of this question, I think. So it gives us the radius of planet X, it gives us the radius of planet Y, both in miles. How many times more surface area is there to map on planet X than planet Y? Okay, so let's calculate the surface areas of both about first. So we know surface area of a sphere is just 4 pi r squared, right? So the surface area of X would be 4 times pi times 6397 squared. I'm going to get square miles for my answer, right? The surface area of Y is equal to 4 pi times 1063 squared. Okay, easy to make those calculations. But how do we do this part? How do we do this part right here? How many times more surface area is there to map on planet X than planet Y? Now, think about it this way. If I know that Mount Everest is, say, 29,000 feet high, and I know that Mount Hood is 11,235 to 45 feet high, something like that. And I want to figure out how many times bigger, how many times taller is Mount Everest than Mount Hood. How would I do that? Yeah, I would divide the height of Mount Everest by the height of Mount Hood. And if I did that, I would find that, roughly, if I just do a rough calculation, 29,000 divided by 11, let's just say 11,200, because I didn't get all of Mount Everest on there. Whoops. Is about 2.6 roughly. That makes sense, doesn't it? Mount Hood times 2.6, a little more than 2.5 Mount Hoods stacked together would be Mount Everest. Okay? That makes sense. We wouldn't subtract or do anything goofy like that. If I subtracted, 29,000 minus 11,000 would be, like huge, like 18,000. That doesn't make sense. Mount Everest is 18,000 times, no way, right? We're dividing. That's how we do this. So all I've got to do then is just calculate these two surfaces and divide. X is going to be a bigger surface, isn't it? Right? It's got a bigger radius than planet Y. So I'm just going to divide planet X, that surface area, by the surface area of planet Y. So let's just calculate those. Surface area of X is 4 times pi times 6397 squared. Huge. So what do we got there? About 514 million square miles. It's pretty big. Surface area of planet Y, 4 times pi times 1063 squared. It's a measly roughly 142 million. Right? So if we divide those two, then the first one divided by the second one. Oops, did I mess that up? Yeah, I did. The first one divided by the second one. 36.21 times bigger. A lot bigger. A lot more surface area on that one planet than the other. Okay? All right, we're getting there. Okay, another one that, looks harder than it is, frankly. We want to solve for X. Now, what is X here? What kind of animal are we dealing with here? What is this guy?
Equilateral.
Okay, not equilateral. And you're right, it is the height. Height of what? What do I call this? Okay, good. A hexagonal prism, right? Because the base is a regular hexagon. So I've just got to find, I'm looking for the height, right? Now, if I'm given volume, when you see volume stuff, just rejoice. Volume is way easier than surface area, right? The volume of a prism is simply base times height, right? That's it, okay? And I'm looking for height. So I can just calculate the base. I'm given the volume, and then what would I do to get eventually to get that height by itself once I know the number? Yeah, divide volume by the number that we get for base, and we're done.
So to get the base, you just stick 12 and then put it to the hexagon. Whatever the formula is.
I'm going to put 12 into the formula for the area of a regular hexagon. Exactly. So the base area then, we can calculate that. Remember, our formula for a regular hexagon is 3 radical 3 over 2 times, in this case, y, side length, squared. Okay, so that's B. Volume is given to us right here. So this is easy. Right? This is no big deal. We can calculate B. 3 times square root of 3, get out of the radical, divide by 2, times 12 squared. There's the number for the base area, right? So the volume is equal to 3494. So I can just divide 3494 by that, right? Base area, and we got it. Oops, I didn't hit enter, did I? So the height is 9.34. Okay, height of the prism. Make sense? Okay. Looks way harder than it is.
What?
Yes. Yeah. Okay, this one also, it looks terrible. Looks absolutely terrible, but this is easy. They give you, this is seriously extremely easy. It looks complicated because the base is a pentagon. Well, how in the world are we going to calculate the surface area of a pentagon? The answer, you don't have to. They gave it to you right there. Okay? Yes?
So is the top of it a cone or?
No, the top of it is a pyramid. It's like we've stacked a pentagonal pyramid on top of a pentagonal prism. But both of those might be difficult to calculate. Travis, why don't you get rid of that? Both of those might be difficult to calculate if you weren't given the base, but you are. You're given the base. So this is easy. That makes this problem no big deal. We know that the volume of a prism, we already said, is just base times height. Both of those things are given to us. We don't have to do any calculations. The volume of a pyramid is just 1/3 base times height. Once again, both of those things are given to us, right? Now, what is, the height of the pyramid is R, isn't it? 3.3. What is, if the whole thing, the whole structure, has a height of H, how would I find the height of the prism? If I'm told that the whole thing is 8 meters high, yeah, just subtract the height of the pyramid from the total height to get the height of the prism, right? So let's do that. The height of the prism then, this distance from there down to here.
So you're subtracting H from R?
I'm subtracting R from H. Right, so this is 3.3. This whole thing right here is 8. So 8 minus 3.3 is what, 4.7? So 4.7 meters is the height of the prism. Okay, and now I just plug stuff in there.
What's the R?
R is the height of the pyramid is R. Tells you that 3.3.
What do you mean with the R?
H2.
Say, okay, question out here. I heard a question. Yes.
Wait, what do you mean? What is R? The size?
The R, no, the R is, it tells you right here, the total height from the peak of this gazebo, right? This is some big outside, I think like a tent, like a big gazebo. The height from the peak down to the floor is 8 meters. Okay, the height of just the pyramid on top is 3.3 meters.
Oh, so it's just the height.
Yeah, so the height, so this distance right here, from there down to there, just the height of just the prism part on the bottom is 4.7. Okay? So then for me to calculate the volumes of and I'm just going to add them up, aren't I? I'm going to calculate the volume of the prism plus the volume of the pyramid equals the total volume. Volumes are simple. You either add them or subtract them. You never have to worry about are any of the sides covered up or bases covered up? Doesn't matter. Volumes, you either add them up, or if you're taking a divot out of something, you might subtract something, but that's it. So let's calculate these volumes. So the volume of the pyramid, let's do that one. That's just going to be 1/3 times base, which is, what's the base given to us as being? 82, right? Times 82 times the height, which is 3.3. So there's the number.
Wow.
That's the volume of the pyramid. The volume of the prism, that's just going to be our base, which is 82 times 4.7, we said was the height of the prism, right? That's it. There are the two numbers that we add up. That's it. So I'll take this one plus that one, and that's my answer, 475.6. Okay? So you got to take your time with that one and make sure you understand what's being given to you, but the math is not hard. Okay, how would we do this one? Base times height. What's the base in this case? Z times y. Height is x, so it's just z times y times x. In fact, when you're calculating volume of a rectangular prism, if you want to, you can always just take the product of the width, of the length times the width times the height. That's it. Okay, nothing to it. And then last one I have for you is one of these. Let's do one more of these like we did yesterday, just for a little additional review, and that's it. We did it all. Yes. In fact, what I'm going to do this for every period today, and I purposely picked, even though we're covering the same stuff, I purposely picked different problems for each class. I'll put them all online, so if you want to, if you feel like you need some review, you can take a look at those. It'll be the same stuff, but just different problems. So I think we covered all our bases on this. The surface area is 16 pi. Find the circumference. Okay, so we got to find r, don't we? By giving us surface area, we've got to calculate r, which we can plug into the circumference formula. All right, so surface area we know is 4 pi r squared, and that equals 16 pi. So how do I solve for r?
Divide by 4 pi.
Okay, divide by 4 pi. Very good.
So it's 4.
So the 4's cancel from both, or from 4 and the pi from the left. Pi's cancel on the right. 16 over 4 is 4. So I get r squared equals 4. So what's r? 2. 2. Square root of 4. 2.
The diameter is 4.
Okay. So if the radius is 2, then all I have to do is feed that into the circumference formula. 2 pi r. So there's my radius, right? So I just get 2 times pi times 2, which is what? 4 pi. Yeah. And I want the answer to be in terms of pi. Leave it in terms of pi. So in Moodle, in my answer box, that's pi, you can read that, I'll just enter 4p, or 4 times p. Done. How about that? Wow. That was a good job. Okay, so